Now I am going to discuss about a few problems which are in the exercise of the first chapter called Electrostatics. I am going to read the problems. The two charges 10 into 10 to the power minus 9 microcoulomb and 20 into 10 to the power minus 9 microcoulomb are placed at a distance of 0.3 meter. So find the potential and the intensity at a point midway between them. So I am going to draw a diagram. For every problem, better you draw a diagram and try to understand. So first charge is 10 into 10 to the power minus 9 coulomb, and another charge is 20 into 10 to the power minus 9 coulomb, and both of them are displaced at a distance of 0.3 meter. 0.3 meter. What is the potential and the electric potential and the electric field at a midway between them? First we calculate the potential. So both of them are a positive charge. So this will offer some potential here, this will also potential. So potential offered by this positive charge can be said as V1. So potential offered by this one can be said as V2. So what is the potential expression? 1 by 4 pi epsilon naught Q by R. So 1 by 4 pi epsilon naught can be written as what? 9 into 10 to the power 9. 9 into 10 to the power 9 into Q by R. 10 into 10 to the power minus 9 by what is R? At the midpoint, the point is at 0.1, whole distance 0.3, the half of the distance is 0.15. 0.15. Similarly, what is the potential offered by this 20 nanocoulomb at the midpoint? So 9 into 10 to the power 9 into 20 into 10 to the power minus 9 by 0.15. So what is the total potential? You have to add the both. Total V is equal to V1 plus V2. Now look at that. What are things are constant? So 9 into 10 to the power 9. When you add this 10 and 20, 30. So 0.15 is constant. So is equal to 9 into 10 to the power 9 by 0.15 into 30 into 10 to the power minus 9. So I am going to cancel plus 9 minus 9 is equal to 9 into 30 by 0.15. Now 0.15, if you want to make as a whole number, you multiply 100 and divide by 100. Becomes 99 into 3 into 30 into 10 to the power 2 by 15. Now divide. 2 15s are 30. So V is equal to 18 into 10 to the power 2 volt. So V is equal to 1800 volts. This is a total electric potential. So one of the answer is over. Now the second one. We have to calculate the total, the electric field. The electric field offered by this positive charge will be pointing towards it, because electric field offered by a positive charge will be pointing outward in all directions. So this can be taken as E2, and this is a bigger charge, we can say as a E1. So the electric field offered by this positive charge is pointing towards, say, E1. So the electric field directions offered by these two charges towards the midpoint will be in opposite direction. So what is the electric field offer expression? E is equal to 1 by 4 pi epsilon naught Q by R square. So E1 is equal to 9 into 10 to the power 9 into 20 into 10 to the power minus 9 by R square, 0.15 square. What is the electric field offered by this particular charge? 9 into 10 to the power 9 into 10 into 10 to the power minus 9 by 0.15 the whole square. Now since the electric fields are actually opposite, if you want to calculate the net electric field, E is equal to E1 plus R minus E2, and E is equal to E1 minus and E2. Now substitute this E1 and E2 in this equation, and what is common? 9 into 10 to the power 9 and 0.15 square. When you subtract 20, 10 minus 20, it becomes 10. So E is equal to 9 into 10 to the power 9 by 0.15 the whole square, 10 into 10 to the power minus 9. You can cancel. So it is equal to 90 by 0.15 the whole square becomes 90 by 15 into 50, 225. But 0.15 into 0.15, 0.0225. So I write here. So electric field E is equal to, in order to make as a whole number, I am going to multiply 10,000 in numerator denominator. So 90 4 zeros by and 225. Now actually I am going to split up this value 900 and for 3 zeros. How many 225s are there? 900. 4 225s. So E is equal to 4 1 2 3. So what is the unit of electric field? You can use either volt per meter or Newton per coulomb. So I use Newton NC minus 1. So total electric field is equal to 4000 Newton per coulomb. So if you use my method, so I am not using either calculator or a logbook, I am using only a mental mathematics. So next sum is, the two charges spheres repel each other with a force of 2 into 10 to the minus 3 Newton. The charge on one sphere is twice the charge of the other. When one of the charge is moved by 10 centimeter away from the other, the force is 5 into 10 to the minus 4 Newton. Calculate the charges and the initial distance between them. So I draw the diagram for this particular problem. So then if you draw the diagram and then when you try to solve it, you can easily understand. So consider here two spheres. The charge of the one sphere is Q, another charge is 2Q, and distance between them is R. And when they are actually, since both of them are positive charges, the force of repulsion is equal to 2 into 10 to the power minus 3 Newton. But if one of the spheres is moved by another 10 centimeter, so it becomes R plus 10 centimeter, then the force of repulsion is decreased 5 into 10 to the power minus 4 Newton. Then we have to calculate what is the R, then what is the QS plus 2Q. Very simple. Now for this first structure, you can apply the electric field force or force of attraction. So what you can apply the Coulomb's law forces. So F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. So I can write 9 into 10 to the power 9 into Q1 Q2, Q into 2Q. So 2Q square, the distance is R square, is equal to 2 into 10 to the minus 3 minus 3. So equation number 1. Similarly, you apply this Coulomb's law forces for the second structure. 9 into 10 to the power 9, Q into 2Q becomes 2Q squared by R square, but force actually reduced to 5 into 10 to the minus 4 Newton. So you can number this as number 2. Now divide 1 by 2. So again, all these values will be cancelled, everything will be cancelled, and this becomes, R plus 10 the whole square, because distance is R plus 10. Then you get R plus 10 the whole square by R square. When you divide 2 by 5, this power gets, so 2 into 10 to the power minus 3 by 5 into 10 to the minus 4 will give you 2 into 10 to the power plus 1 by 5. So it becomes 20 by 5 is equal to 4. So remove the squares on the left hand and right hand side. R plus 10 by R is equal to 4. 2. Now cross multiply, R is equal to 10 centimeter. So if you want to express in meter, becomes 0.1 meter. So the first answer is calculated. R is equal to 0.1 meter. Next, we are going to substitute that R in the equation number 1. So this is the equation number 1, this is the equation number 2. Substituting R in 1. Look at the expression. 9 into 10 to the power 9 into 2q squared by 0.1 squared. So in the place of r square I am writing 1 squared into 2 into 10 to the power minus 3. Our so the 0.1 square can be written as 0.01. 0.1 into 0.01. It is equal to 10 to the power minus 2. So 2q squared can be written as, this 2 can be cancelled. This minus 2 and minus 3 will go on top, becomes 10 to the power minus 5. And by, this will come down 9 into 10 to the power 9. So q squared is equal to 1 by 9. This 9 will goes on top, 10 to the power minus 14. So when you remove the square, q is equal to 1 by 3 and 10 to the power minus 7. So what is 1 by 3? Q is equal to 0.3333 into 10 to the power minus 7 coulomb. So when you put the point 2 digits on towards the right hand side, so Q can be written 33.33 into 10 to the power minus 9 coulomb. I hope you are following me. And Q is equal to, and minus 9 can be written as nanocoulomb, 33.33 nanocoulomb. So we have calculated the value of the Q. So what is a 2Q charge? So 2Q is equal to 2 into 33.33 nanocoulomb, and 2Q is equal to 66.66 nanocoulomb. So we calculated what was the R distance between the two charges and what was the one of the charges. From that, since the second sphere has got twice first charge, then Q is equal to 66.66 nanocoulomb. So we have covered elaborately the different chapters covered in the first topic of electrostatics. With that, we will come to end of this electrostatics. Then we will see the next class regarding the topic name is the current electricity.